Okay, we're going to be talking about continuity at a point. And the first thing I want to do is just do a little discussion on continuity, give some examples, and then move on. Alright, well, this is where we're going to start here. This is the definition of continuity, and we're going to be looking specifically at continuity at a point. We say that a function is called continuous. Alright, that's supposed to be continuous there. At C if the three of the following conditions are met. So the first thing, you want to find f of C and make sure that it exists or it's defined. Then we're going to look for the limit of f of x as x approaches C. It has to exist, and the limit of f of x as x approaches C, it must be equal to f of C. Let's look at some examples of this. Now, actually, before we leave here, I should say this. It doesn't really matter which order we do these two here in, but as long as we get down to this point here to see if they're both equal. So let's look at some examples. Okay, the first thing I'm going to look at here is -6. We're going to take the limit of the function as x approaches -6, and that means that we need to check it from the left and check it from the right. Now, of course, you can see here that these both are two different numbers here, which means that this limit does not exist. But remember, this limit had to equal, or this limit had to exist, okay? And then the other part to this was that f of -6 must exist, and it does, but these two must be equal to each other. But let's look at the graph so you can get a better idea of what is this f of x. Okay, well, I've just got it graphed out. Here's -6 right here, and so finding the limit as x approaches -6. Now remember, coming in from the left-hand side, okay, it was 4. All right, coming in from the right-hand side, it was 6. And so forth. You can see here that the graph is broken, but therefore the limit doesn't exist. And when we looked at f of -6, remember f of -6 was 2. Okay. Let's look at this right here at -2. Now there's supposed to be a vertical asymptote right here, so the limit doesn't exist at this vertical asymptote, or I should say more precisely here, at x is equal to -2. The limit doesn't exist, so we know it's not continuous here. And I should say back over here it's not continuous, right? Because the graph is broken. Alright, what about at 2? The limit is not continuous because the limit as x approaches 2 doesn't exist. The left-handed limit is 6, but the right-handed limit as x approaches 2, we just follow the graph down, is I don't know what that is, something over here, I don't know, something a little bigger than 2, I guess. Let's go back down to our chart. Alright, let's go back to -2 here. So we were looking at if the graph, if our function was continuous at -2, and we were doing that just examining the graph. And you can see coming in from the left-hand side that the graph was going down to -infinity, and coming in from the right-hand side it was going to -infinity. Therefore this limit doesn't exist. And even worse here, f of -2 is undefined here also. So, right, this doesn't meet any of the criteria, those three possibilities that it's supposed to meet. We were looking at, I think, 2 on the next one. As x approaches 2, now coming in from the left it was 6, coming in from the right, that was that number there I was trying to figure out what that was. It's -2.5, so neither of these are equal, right there. Okay. Where was I at here? We were going from -1, or I'm sorry, we're approaching 2 from the left-hand side. We got 6 approaching 2 from the right-hand side. We got -2.5, therefore the limit doesn't exist. So for this to be continuous at the point where x is equal to 2, this must exist, but it doesn't. So we know right there that it's not continuous. But another thing to check is we got to check f of 2, and of course it is defined and it happens to be equal to 6, but it's not continuous. Okay, let's look at 3. Let's look at the graph first. Alright, so 3 is located about here on the x-axis. Now, I've got this circle, this white circle here indicates there's a hole in the graph. But we're going to go through and systematically check this. So the first thing we're going to check is we're going to check the limit as x approaches 3, and then we're going to check f of 3. Okay, so we're checking the limit of f of x approaches 3. That means we have to check it from the left, and it was equal to -2. And we're checking it from the right-hand side, and it was also equal to -2. Therefore, we can say that the limit of f of x approaches 3 is -2. Now, the second thing we have to check after we've checked the limit, does f of 3 exist? And if it does, what is it? Well, sorry, but it's undefined. Therefore, for it to be continuous at x equals 3, this has to exist, but it's undefined. So, not continuous at x equals 3. Let's look at some others. Alright, what about here when x is 6? Okay, so the black dot here just means that it's just a point on the graph. Well, remember, the white dot meant that this was actually a missing point on the graph. Okay, so we need to check the limit of our function here as x approaches 6. Well, when we come in from the left-hand side, right, so just pick somewhere on the x-axis just close to 6 on the left, go straight down, find the graph, and then we just kind of ride the graph as x gets closer and closer to 6 from the left, and it's looking like, I believe that's 2 there. So, and so coming in from the left, it's 2, and then we do the same thing coming in from the right-hand side. We see that the y value is going to 2, right? So as x gets closer and closer to 6 from the right, the y value is getting closer and closer to 2. So the limit of f of x as x approaches 6 is equal to 2. Now what about f of 6? Well, f of 6, that means you take 6, plug it directly into the function, and that point, since it's defined right here, f of 6 is also equal to 2. Therefore, it is continuous at x equals 2. But remember, we must write it out, right? So we checked coming in from the left, coming in from the right. These were both equal. Therefore, the limit of f of x approaches 6 is -2. We plug 6 in to our function, and of course, we just got our graph to look at, and we see that it's equal to -2. Alright, let's look at another one. What about the limit as x approaches 0? So that'd be the origin right here. Well, if we were looking at the limit as x approaches 0, we'd clearly see that there's no holes or jumps in the graph right here. So we could see that it is continuous at x is equal to 0, and I'm not exactly sure what the y value is, but this is 2, 4, 6, I don't know, maybe 5 or something like that. But anyway, so there's the idea about what it means for a function to be continuous at a point.